Am I audible?
Good evening, sir. Audible, sir.
Okay, let's start the session. So already we are 6:10. Time is around 6:10. So we'll start the session. So my screen is visible to you guys, right? Okay. So once again, good evening to all. So we are going to discuss environmental remediation of contaminated site course. So course instructor of this course is Dr. Banu Prakash Velanki. So myself, I am SV Chinnaswamy, a PMRF scholar from IIT Roorkee. So before going to previous year week 11 assignment questions, so we'll briefly discuss uh, overview of uh, week 11 content. Okay, the first topic we discussed, that is new topic, new method we introduced for remediating any contaminated site, that is soil vapor extraction. So what is the difference between the other techniques and the soil vapor technique? So here we are considering this technique like cheaper technique compared to many other techniques, because we here and better technique we are considering it is very uh, very easily manageable and very less very less hard work. We can easily contaminate we can easily remediate the contaminants. We can easily remove the contaminants from the soil or water. So what we are doing here, simply we are not adding any reagents or chemicals such. So we are just introducing the air, I mean gas, to the contaminated soil media or liquid media, and then whatever the NaPl, DNaPl, LNaPl, mostly I mean to say hydrophobic contaminants. What will happen? These contaminants will change the phase from the solid phase to a liquid phase, and this solid phase to a gaseous phase. This gas will be collected through the wells and collection wells from the, so few more things we have to consider, like we have to place the impermeable layer, right? Suppose it is the contaminated soil and this is the water table. So contaminated soil or contaminated groundwater, so we introduce gas here, and the collection pump wells will construct, and from this whatever the uh, contaminants which changes phase from liquid to gaseous or solid to gaseous, so we'll collect from the gaseous phase. So we don't want to expose these released contaminants to the environment. So what we will do, we'll construct an impermeable layer here. So and that too, and for again we construct one vacuum source well here. So here we'll introduce the vacuum, so that we can effectively collect the uh, contaminants from the site. So this is the main procedure of this soil vapor extraction method. So in this method again we discussed like how to calculate the total mass of contaminants to be removed. So like as previous techniques, how we remove how we determine total mass. So as we derived the equation for total mass of contaminant to be removed from the previous technique. Similarly, uh, we are coming with new phase, that is gaseous phase. We are adding just extra term, that is gaseous term. We are adding to extra this term to the previous formulas. So again we consider that finding the total mass of contaminant to be removed in the presence with the presence of NaPl. If there is no NaPl, what will be the formula? If it is NaPl is present, what will be the formula? Both formulas is derived by the course instructor, so I'm not going to discuss it. And after that, we discuss like design part of soil vapor extraction method. So soil vapor extraction method, mainly four things we have to find out. So one is like estimation of total mass of contaminant to be removed. So that is as I discussed earlier, like we discuss total mass of contaminant to be removed if there is NaPl or if there is no NaPl. So we have derived these two formulas. By using these two formulas, we can estimate the mass of contaminant to be removed from the contaminated cell. And then second parameter we have to consider while designing this soil vapor extraction is effect of gas flow on radius of influence of well. So effect of gas flow. So as we are introduced here suction pump or vacuum. So we created vacuum. So as we move away from this vacuum pump, so the flow rate of the flow rate from that particular point to as we go away from the radius radius from that vacuum pump, so our flow rate will be reduced. So we have to consider that one also. So with help of with effect of radius of influence, so how is the gas flow is varying, so that we have to calculate. And then number of wells we have to place, and the flow of each well where we place those, and finally we have to estimate the time required to remediate the site. So these are the major four things we have to consider in the design part of soil vapor extraction, right? Okay, so these are related to design part. So already course instructor discussed one example. So he calculated all the four parameters with help of one example. So I don't need to discuss it again. And then next topic, is covered by yeah. So this is the similar case. It is a case study, soil vapor extraction case study, again discussed by the course instructor itself in the recording sessions. So generally this mainly this soil vapor extraction case study uh, is it's telling about the TOU mount facility area. It's actually it is Miamisburg in USA, actually Ohio state, I think. And main contaminants here they try to focus remove they the contaminants which are PCEs, TCEs and DCEs. These are the VOCs, volatile organic carbons compounds. So chlorinated compounds here we have to remove. And the method, what are the method, which method they use, that is soil vapor extraction method they used. uh, and then coming to the next topic, that is bioremediation. So bioremediation, we consider the cheapest method for remediating any contaminated site, because as here we are not spending much money compared to other techniques, because we are just simply introducing the microbial strains to the particular contaminated sites, and with help of microbial activity, so we are trying to degrade the contaminants, or we are we are solidified the we are trying to immobilize the contaminant, or we are trying to degrade the contaminant, right? So here in this bioremediation part, we have been discussed different various methods we have in remediating such things like bioremediation, phytoremediation. Again, it is related to plant. Just whatever we just uh, we just whatever we just plant the different types of crops in the contaminated site. So these plant will extract the contaminants through the roots uh, from that contaminated site. So this is called phytoremediation. With help of plants we are just degrading the contaminant or transforming the contaminant from one place to another place, or we are just trying to immobilize the contaminant. So similarly, biodegradation, again it is a partial degradation of contaminant with help of microorganism. And again mineralization, it is a complete degradation. So whatever the contaminant will be there is completely mineralized or degraded by the microorganism, and the byproducts we generally we get H2O and CO2 as a byproduct. Similarly, we discuss co-metabolism, bioavailability consortium. So and then different different requirement conditions, different condition required to effectively promote the microbial growth. And after that again we discuss what are the factors affecting in the bioremediation. It majorly generally three factors majorly we are considering as a effect in the bioremediation. Those are bioavailability. So it is very difficult to provide such condition to grow the microorganism, because microorganisms are very sensitive and we have to maintain the atmosphere to survive the microorganism, like such temperature, pH and oxygen. So these are the conditions we have to maintain. Again it depends on, it varies different microbial strains. These conditions varies different based on their different microbial strains. So again heterogeneity. So heterogeneity we have to consider, because whatever the contaminant sites we choose there, so there is no guarantee that there is no okay, there is no guarantee that like permeability or pH or different condition will be same throughout the contaminated site. So there will be a heterogeneity. So this heterogeneity also will affect on the survival of growth of the microbes. And then kinetics. So when it comes to the kinetics, it is about time, right? So time bioremediation we have considered as the slowest process compared to other techniques, because microbes takes a very long time to degrade the contaminants. So this is the slowest process, and then because of this time consideration, kinetics also affect in the bioremediation. Next one is the respiration. So respiration in generally in respiration, what happens is you need here one electron donor and electron acceptor combined together, will take a reaction will take place, and there will be a oxygen storage or byproducts such as hydrogen and CO2 will get. So here most of the times oxygen we consider as a electron acceptor, but because if you consider the order of, if you have oxygen oxygen or nitrates, ferrous, and sulfides. So if all these compounds are present in contaminated site, so if you introduce the microbes, which compound will consider as a these microorganisms consider oxygen as a majorly electron acceptor as a uh, major source, and because it is having more oxidizing, oxygen is considered as a more powerful oxidizing agent. So even presence of other compounds also, bacteria will choose oxygen as a oxidizing agent, as a electron acceptor compared to other compounds. So the here in respiration process, oxygen is the main source for as a act as a main source as a electron acceptor, because again one more thing, even in soil vapor extraction also we are supplying the air, so air contains oxygen. So again here supplying air also, it will stores oxygen, act as a sorry, this air, whatever the oxygen present in the air is act as a oxygen reservoir for growth of microorganisms. And here in respiration part we have been discussed different off reactions for like related to magnesium oxide, ferrous, and ammonia, so which act as a storage of this reaction act as a storage of oxygen. So and similarly with case of anaerobic condition and aerobic condition we discussed. And then methane production. So next topic is methane production. So generally why we consider methane as a methane compound in the remediation part, because of it helps in dechlorination. So whatever the chlorinated compound which is there in contaminated side, we consider those are the major contaminants. So with help of these methane act as a this methane helps in dechlorination process. So that's why methane production is important in bioremediation. So most generally we produce methane with the help of two processes. One is fermentation and second one is respiration. So in fermentation what happens, so complex organic matter will be degraded into simple organic matter and other byproduct like H2O and CO2 such. So these complex while decomposing this complex organic matter into the simpler organic matter, so this simpler organic matter will produce methane, that is CH4 sorry. So again here in the most of the cases we saw similar case study here also. So in most of the cases what we are doing to produce the methane, we are adding molasses. Actually molasses added to the bioremediation process because it acts as an electron donor. So generally molasses is byproduct of sugarcane processing. So while processing the sugar from the sugarcane, so whatever it is, the molasses is the one of the byproducts. So these molasses we are adding in the fermentation process, I mean in bioremediation of in the bioremediation process, which act as a electron donor. So we have been discussed, that is case study related to bioremediation with help of dechlorination, anaerobic dechlorination. So bioremediation case study, that is Williamsport area and Pennsylvania, which is located in USA. So major contaminants here what they try to remediate is TCs, again DCE and vinyl chlorides and hexavalent chromium and cadmium. So what is the main mechanism, what mechanism they choose to remediate that contaminated site is anaerobic reductive dechlorination. Reductive dechlorination. So we already discussed that dechlorination will occur with help of methane. So in that methane can be generated from the fermentation. So in the fermentation process we are adding molasses which act as a electron donor, right? So if you discuss the case study, the results of this case study, so we have been observed that the concentration of TCE, DCE and hexavalent chromium have been reduced below their cleanup goals in many monitoring wells at the site. Similarly, the concentration of hexavalent chromium have been reduced by more than 99%. Similar case with TCE. TCE also the concentration is reduced around 90%, right? And again DCA also the concentration of DCA initially increased from 7 to 100 microgram per liter, but after 10 months of the treatment, indicating that successful dechlorination of TCA, then decreasing it from 19 microgram per liter by the July 1998. They consider uh, it as a they consider as a DCE initially increased and then it is reduced after that. So that's all about uh, the overview of week 11 content. So now we'll discuss previous year assignment questions. If you guys have any doubts, we'll have a brief discussion about it. Otherwise, we'll move to the previous year assignment questions. Any doubts, please? Okay. Okay, then we'll move to the assignment questions. So that is week 11 assignment question, previous year question it is. So coming to the first question, so match the following process with their explanation. So they gave different process, uh, bioremediation process, biodegradation, mineralization, phytoremediation, and the process. We have to match the options, which is the best correct option for matching this process and explanation. So biodegradation. So what is the biodegradation? Anyone please? A, B, C, D. So A is the living organism either degrade, transfer or immobilize the relevant contaminant. Biological processes are used to degrade compound. Plant and bacteria near the root or rhizosphere degrade or transfer relevant contaminant from one phase to another. Degrade the compound to such an extent that you end up with CO2 and H2O. Biodegradation. Which explanation better suitable for biodegradation? A, B, C, D. Which one please? Anyone? Best suitable explanation for biodegradation. I think it is B, right? Yeah. So biological process, biodegradation is just a biological process, no other process involved in it to degrade the any compound, uh, any contaminant. So second one, mineralization, degrade the compound to such an extent that you end up with CO2 and H2O. Yes. So mineralization we consider it as a complete degradation. So the byproducts we generally end up with CO2 and H2O. And bioremediation, yes, A. So living organism either degrade, transfer or immobilize the relevant contaminant. Phytoremediation, we already know that phyto itself represents the plant. So with help of plant, so we are trying to just transform the relevant contaminant from one phase to another phase, from soil to plant, it changing the phase from solid to liquid or liquid phase by extracting through the soil plant roots. So option is C, I guess. One is B. Mineralization is D. Yes. So answer for this question A is C. Question number 2. So land forming, which is an ex situ remediation method used to remove contaminant from the soil, requires an impervious layer between land and contaminated soil to prevent the leaching. So is this statement is true or false? Land forming, which is an ex situ remediation, the method used to remove the contaminant from the soil, requires impervious layer between soil and land. Yes, it is true, because so we don't want to leach our contaminant from the soil to groundwater or such. So for that we have to provide impervious layer, because it is ex situ remediation method. So yeah, answer for this question is true. And question number 3, select the various indicator which can be used to indirectly measure the amount of microbial activity. So how can we measure? So it is very difficult to measure the microbial activity. So we can't count, because microorganisms are, so we can't see those microorganisms, all of the above. So we can't see the microorganism with our naked eye. So it is very difficult to measure the microbial community. So we use indirect parameters to measure the microbial activity. So with respect to the change in pH, uh, change in pH of that particular soil or water, or amount of oxygen they consume. So for survival, oxygen, for microbial growth, oxygen is needed. So if that any water contaminated, groundwater or contaminated soil is consuming more oxygen, that means there is more number of uh, microbial community. Similarly case with pH, generally pH at 6.5 to 8 pH, microbial activity will be good. So if the pH is maintaining such, if water or contaminated water or soil is maintaining such pH, then we can conclude that the microbial activity will be there. And change in CO2 concentration, of course the end product they release CO2. If more concentration is decreased, increased in soil or water, we can assume that there will be a more microbial activity. So all the above is the right answer. So question number 4, select the component which are essential in soil vapor extraction method of remediation. So we discussed, right, different components we install in the contaminated site in the way of soil vapor extraction method, which are the select the correct components. Vacuum source, right? Vacuum source we introduced, yes. And what about extraction well? Extraction well also we introduce. Injection impervious layer, it im, im, impervious layer also needed, right? See, sorry, you install the vacuum source here, and injection well and extraction wells. So if you see, in injection, through injection well we are supplying gas. So whatever the contaminants which is there in water or soil, so it will change the phase from liquid to gas or solid to gas. So what will happen, these gas contaminants in the gaseous phase will evaporate to the atmosphere if you don't provide the impervious layer. So impervious layer is also needed in the soil vapor extraction method. And monitoring wells, yes, monitoring wells is needed in every method it is needed monitoring wells, so that we can conclude that whether the contaminants concentration are increasing, decreasing, or increasing. So with help of monitoring well only we will measure the concentrations. So the answer for this question is all option is right. Question number 5. Select the correct statements regarding soil vapor extraction method. Again, here they discuss few advantages and disadvantages. So option A, they are saying advantage: no use of reagent is required. Is it correct? In soil vapor extraction method. So they are saying advantage is because we are not using any reagents or chemicals in this method. Is this option is true? Yes, true. Because we are supplying only air, not in, we are not injecting any chemicals or reagents. And about A and D. So if D, if you in D, okay, in D what they are saying disadvantage: soil needs to be permeable as it impacts remediation efficiency. Yeah. So if soil is permeable, of course it is disadvantage, because all the contaminant which change from the liquid phase to gaseous phase will permeate. If its soil is permeable, easily it escapes and it effect on the remediation efficiency. What about B and C? Advantage, they are saying soil permeability doesn't impact on remediation efficiency. It is not advantage because it is disadvantage. Because of course they are saying doesn't impact, it impacts soil permeability. So already we discussed in option D. So soil permeability will impact on the remediation efficiency. On option C, disadvantage, they are saying method leaves some chemical residues. So there is no chemicals we are adding, then why should we get residues of chemicals? So we won't get. So option A and D is right. Option A and D is right. So question number 6. So bioventing, bioslurping, and heat treatment are the method of enhancing the soil vapor extraction process. Is it true or false? Bioventing, bioslurping, and heat treatment. Think about once again. So here they are mentioning that bioventing and yeah. So but here they are talking about soil vapor extraction, not bioremediation process, right? So these are the methods which is related to bioremediation, right? I think so. Bioventing and bioslurping and heat treatment. So heat treatment is required in soil vapor extraction, maybe, but in bioventing, bioslurping is which are related to bioremediation process, not soil vapor extraction. So the statement is true or false? False. So next, question number 7. Select the correct advantages of bioremediation process. Option A, no reagents are required. Is it true? So they are talking about bioremediation process, not soil vapor extraction. Reagents are required. So what reagents we are using in bioremediation process? In bioremediation process, we are introducing only microbial community. Yeah, no reagents are required. It is correct. So we are not adding any chemicals or reagents. And okay, the kinetic process is very fast. Is it true or false? Bioremediation process, they are saying kinetics is very fast. False, because kinetics is very slow in bioremediation. Microbes will take a lot of too much time to degrade contaminant. It is very slow process. What about the soil doesn't need to be homogeneous? Is it true or false? False, yes. Because if if the soil is more homogeneous, then only we can easily promote the growth of microbial community. If it is heterogeneous, it is very difficult to promote the growth of microbial community, because the condition, the parameter and condition, whatever the maintaining we are trying to maintain for microbial growth, such as pH or oxygen supply or temperature, those things will maintaining uniformity in the heterogeneous soil is very difficult. So soil, homogeneous soil is needed. And third the option B, complete degradation of contaminant is achieved. Is it true or false? See, in biodegradation, so complete degradation won't occur, but in mineralization complete degradation will occur. But in bioremediation there is no guarantee 100% biodegradation will occur. So there will be chances, more chances are there, few contaminants still will be not remediated with the microorganisms. So this statement is false. But if they mention mineralization, this statement is true, because in mineralization complete the microbial community completely mineralize the contaminants, whatever the contaminants. But here in bioremediation, though any particular community, those can degrade only particular compound, uh, particular contaminant. So the particular component, sometimes the contaminant which is hexavalent chloride as such, cadmium, the micro may not degrade those compounds. But when it comes to the mineralization, it will microbes can completely degrade. But this statement, but bioremediation is that we can consider as a partial degradation, or but we can't consider as a complete degradation. So option for this question is solution for this question, answer for this question is A. Question number 8. Select the correct statement regarding the case study, that is alpha-lycomine superfund site, that is related to dechlorination in bioremediation, right? So they are asking few questions, they mentioned few points, and we have to choose correct statements. They mentioned few statements, 4 statements. Statement 1 is molasses was used as an electron donor. Is this statement true or false? Yes, true. So we are adding molasses because it acts as an electron donor for methane production. We need in the fermentation process, for methane production we are adding molasses, because methane is helps in dechlorination, right? Second option, statement 2, the mechanism adapted was aerobic reductive and dechlorination. Aerobic reductive dechlorination. Is this statement true or false? Pertaining to this case study, so they opt for the anaerobic, not aerobic, anaerobic reductive dechlorination they opt. Okay, right? So option B is false. And coming to the option C, site was contaminated with TCE, TCE, VC and hexavalent chromium 6. Yes. So after injection of molasses, oxidizing condition prevail inside. Is it true or false? False, because here molasses acting as a electron donor, not accept. So not an oxidizing agent, right? So solution for this question is A and C. Question number 9 and 10 that gave common data for question number 9 and 10. So what they're doing, a factory has been contaminated by vinyl chloride. Okay, so and the factory is to be remediated using soil vapor extraction. Okay, soil vapor extraction method we have to use. The following data is provided from the from field test. Okay, here the distance they give and vacuum for particular discharge of air supply discharge they give, but for pertaining to this discharge of air supply, how much vacuums it is they maintain. But because we know that already from vacuum pipe radius of influence we discussed, right? So as we move away from the vacuum source, so this whatever the vacuum air supply which is created vacuum, so whatever the vacuum we created here, that will be decreased as we move away from the vacuum source, right? So as distance move away from the vacuum source, so we have seen that vacuum, so they mention in the unit inch of H2O, so it is decreased, right? What they are asking, and they gave physical characteristics such as Wadov zone thickness, that is Wadov zone nothing but it is unsaturated zone. If it is fully saturated, there is no air, so we can't even it is very difficult to supply zone. But it is unsaturated zone, that is thickness of unsaturated zone is 4.5 meters, and volume of soil they give, and gas porosity and liquid porosity, and bulk density, and fraction of organic matter in soil, and dimensionless Henry's constant, and partition coefficient, that is 0.96 liter per kg. And what they are asking us to calculate is the contaminated site has an average gas concentration, that is 16 gram per meter cube, assuming no NaPl is present. Yes, so we have to use the formula where we haven't considered the NaPl presence. So we already course instructor already derived two equations. One is in the presence of NaPl, second one is when there is no NaPl. So we have to use no NaPl formula. What they are asking, total mass of contaminated to be removed, total mass of contaminant to be removed in kgs we have to calculate. So we have to use, I am writing formula directly, so without NaPl, right? Without NaPl formula, that is total mass to be removed equivalent to volume, concentration of gas, porosity of liquid or water, and Henry's constant, plus bulk density, partition coefficient, again upon Henry's constant, plus total gas porosity. So I think all values are given directly in the question itself. So volume, that is 3500 meter cube, and concentration they give, and so volume in meter cube, so concentration also they gave in gram per meter cube, so 16 gram meter cube. So maintain all units in meter cube only. So finally we will consider whatever the concentration we get in grams. or otherwise here itself we can convert in kgs. 10 power minus 3 gram to kg. So porosity of liquid porosity 0.05. So Henry's constant, dimensionless Henry's constant 0.196. Plus bulk density 1850. So it is kg per meter cube. So we are maintaining in kgs and meter cube. So no need to convert. And kp liter per kg. Here again they mention here liter. So we have to convert this liter to meter cube. So 0.96. So Henry's constant 0.196. So as we mentioned that we have to convert this liter to meter cube. So converting 1 liter is equal to 10 power minus 3 meter cube, that is divided by 1000. I am dividing here. So plus porosity of gas 0.24. Please can someone calculate and tell me the answer? So answer will directly come in kgs. Five 35.145 am I right? In kgs, right? Okay, so that is the answer for this question, that is 535.154. Next question, the final question is the radius of influence in meter for discharge 0.015 meter cube per second is dash, and take the threshold to be 1 inch of H2O. So what they are asking, radius of influence. Already they gave, pertaining to this discharge, they gave radius of influence from vacuum source and vacuum generated in that particular distance at particular radius from the vacuum source they give. So what they are asking, we have to consider 1 inch threshold to be 1 inch of H2O, that will fall in between 2.1 to 0.8, right? And yeah, so the distance will be 30 and 35. So here at threshold, at what they are asking, at threshold 1 we have to calculate. So it is directly what we have to do, we have to calculate we have to just do linear interpolation. So radius of influence we have to calculate in meter, so that will be fall in between 30 to 35. So just radius of influence we have to calculate for particular pertaining to 1 inch of H2O, 1 inch of H2O threshold. So I am considering 30 as a x1. So x2 is unknown, that is pertaining to uh, 1 inch of H2O. It will fall in between 30 and 35, and 35 is the x3. And again here I am considering y1 as a 2.1 and y2 equivalent to 1. Sorry, y2 and y3 equivalent to 0.8. Just do linear interpolation. So you know the linear interpolation formula, that is x3 minus x1 x2 minus x1 equivalent to y3 minus y1 y2 minus y1. So what we have to do, we have to find out the x2, right? That is the unknown. So remaining everything no. x1 we know, x2, x3 we know, y1, y2, y3 we know. So what is the x3 here? 35. 35 minus x1 is 30, and x2 we don't know, that is unknown. x1 is 30 equivalent to y3 is 0.8, y1 is 2.1, and y2 is 1, y1 is 2.1. So now calculate what is the x2. It should be fall in between 30 and 35. Please someone calculate and let me know the x2 value. That is related to radius of influence. Radius of influence are pertaining to the 1 inch of H2O vacuum. .23, okay. So it is in between 32 and 30, yes. So answer is right. So that is 34. It is in meters, right? Okay, meters. So 34.23 meters. So I think we completed all the questions. So if you guys have any doubts, you can ask. So, good evening to all. So, today we are going to discuss the week 11 topic, which is discussed by course instructor. So, in this week 11 session, we have been discussed a new method for soil remediation, right? So, contaminated soil remediation. So, that is soil vapor extraction, and one more new method we discussed, that is bioremediation. So from past 10 weeks we have been discussing many remediation techniques and methods, but in 11 week 11 content, so we have been introduced new technique, that is soil vapor extraction, and addition to this we have been discussed one more method, that is bioremediation. So in this week 11 content, so we are going to discuss these two techniques for remediating contaminated sites.
Yes, we need to consider the table, sir.
Sir, sorry.
First subdivision, so there is no LPL. We come to LPL, what is that LPL?
Your voice is breaking. You are asking something NPL.
Yes, the last question.
Okay, last question. No NAPL is present. Okay, last question you are asking. So what you are asking, can you repeat once please?
Sir, in that first subdivision, sir, there is no need to consider the table, right?
No need to consider.
The table has asking the total values are given only for the second question.
Yes, but here they mention that in question itself it is common data for question 9 and 10, but for question number 9 it is not required, because we don't in the if you can choose if you consider this formula, we don't need this table, but this table will be helpful to solve the question number 10. Okay.
In the first question, it is for total mass calculation. Is equal to volume of soil. This is
Okay. Yes, total volume we consider volume of soil only. So because yeah, so volume of soil in the sense it is wado zone. Wado zone nothing but soil is there, water is there, and it is air is also there. So in that whole soil area,
everything is included.
everything included, but
because I think
everything included, but we consider it is as a soil area only. So in this volume,
because that value zone is given separately, so that's why I asked.
Vado zone given separately, it means that only 4.5 meter of thickness of vado zone is there. That represents that in this vado zone it is unsaturated zone. Unsaturated zone means there will be air gaps. Air gaps will be there. That is filled with air, and water will be there, and soil. Mostly soil will be there, in soil pore, whatever the pores, some of the pores are occupied by water and some of the pores are not occupied by water. It is just unsaturated, we are considering. It means that those pores are occupied by air. So it is partially saturated, means some of pores are occupied by air, some of pores are occupied by water. So means considering including all together, we are considering this total volume of soil. But it just they are mentioning that
Okay, sir.
water zone is they just representing thickness, how much thickness the water zone is present, like that they are mentioning. But it's this volume is related to combined to all. So that's why we are considering the porosity of water and porosity of gas and all. Any
Okay,
doubts?
sir.
Yeah, any doubts,
The
please?
question was like why this information was not used in solving the answer.
Question number, this table,
No, this
water zone.
what was yeah, was given as 4.5 meter,
Yeah, yeah, yeah.
but nowhere it was used to
Yes.
solve the problem.
Yeah, it is nowhere it is. They just mention it is for our idea. So like typically, generally, what people used to do, if they mention like soil, generally what we consider, we don't have any idea. Like for suppose I'm just drawing the picture. So this is the soil layer and it is the water table. So water table nothing, means there is no only water. It is soil is also there, but water is present. So here in above the groundwater, only soil is there. So now, if you want to consider the water zone, so if due to the capillary, there might be different reasons due to the capillary or some other rain, or what will happen, whatever the soil will be there, this water will, due to capillary, the water will be goes upward, and whatever the pores in the soil will be filled by the water at some point. So there will be a no guarantee like everywhere capillary will occur. So here some portion will capillary will occur, and whatever the portion covered by capillaries, those pores are filled by the water, and remaining pores are filled with air. So they are mentioning that water zone nothing but partially saturated. So it's partially filled with water. So this much thickness. So if they didn't mention water zone, we'll consider it as a fully saturated or unsaturated. That will be different case. So we might be confused like till what depth this fully saturated zone will be there. So for this, to just give an idea about this water zone saturated unsaturated thickness, they just mentioned, but nowhere we used. If in some cases we might be used, if in the case where instead of volume, if they give just area of this water zone, in that case we have to use thickness to calculate the value, right? So but in this case they directly give the volume, so we don't need thickness. So if in some other problems you might find that they just give the length and width of the water zone and thickness of the water zone, and then we from that length and width and thickness we have to
Okay,
calculate
thank you,
value.
thank you. Got it, got it.
Okay, thank you. If you guys have any doubts you can ask, otherwise you can leave.
Thank you, sir.